Good day, viewers. You're welcome to Understanding Chemistry. Today's lesson, we're looking at rate laws and orders of reaction. The previous video, we talked about rate of chemical reaction and factors that affect the rate of chemical reaction. So one of the factors that affects the rate of chemical reaction is concentration, catalyst and the rest. So the most important factor that affects the chemical reaction we're discussing is concentration. So we know that rate of chemical reaction increases as concentration increases and decreases with decrease in what? Concentration. So we're looking at rate laws. So we know that, let's look at this equation on the board. So rate varies. Rate is directly proportional to the what? Concentration of the species, that's of the reactant. Remember, the square bracket represents concentration. Square bracket represents concentration. So the product of the concentration. Okay. So raise to the power of the coefficient. So if I introduce the constant, I'll remove this what? This symbol of proportionality and introduce the constant. So what I'm putting on the board is what we call rate law. So this small letter A represents the order of reaction with respect to A, and this small letter B represents order of reaction with respect to B. A plus B. The sum of A plus B is overall order of reaction. So this overall, the order of reaction is determined experimentally. Sometimes you cannot predict it through a balanced chemical equation, but through what? Experiment. K is what we call specific rate constant. Specific rate constant. So the unit of rate constant depends on the order of the reaction. For a zero order reaction, this is the general formula for specific rate constant. 1 minus n. So 1 minus n per seconds. So this capital M represents mole per liter or mole per dm cube. So 1 minus n signifies what? Order of reaction. So for a zero order reaction, this is 1 minus 0 give you 1. So it's like saying mole per liter per seconds for a zero order reaction. If it's a first order reaction, 1 minus 1, n being first order, 1 minus 1 is 0. So anything raised to the power 0 is what? 1. Anything raised to the power 0 is something as what? 1. So for first order reaction, unit of rate constant is just per seconds. Second order reaction, 1 minus 2. So we should give you minus 1. So rate constant is constant at a particular temperature and changes at the temperature what? Changes. That's why I normally quote rate constant alongside it what? With temperature. So I want to say something that order of reaction is an integral value, a whole number, ranging from 0 to 0, 1, you can have first order, 0 order, first order, second order, third order, and so forth and so forth. It can also be what? Fraction. It can also be what? Negative. So in this lesson we're looking at 0 order, 0 first and second orders of reaction. What's zero order reaction? It's a reaction in which the rate of reaction is independent of the concentration of the reactant what species. So examples of zero order reaction include what? Photosynthesis in plant, some enzyme catalyzed what? Reaction, and some reaction that take place on solid surfaces. For example, decomposition of ammonia on molybdenum surface, decomposition of hydrogen iodide on gold surface, etc. Okay, so look at this reaction. A reacting plus B. The rate of reaction will be condensation of A, the reactant, raised to the power 0. Since it's a zero order reaction, so raised to the power of what? 0. So it simply means that rate will be equals to what? Anything raised to the power 0 is equals to 1. It's equivalent to 1. So it means that for first order reaction, the rate of reaction is something as what? Rate constant. So zero order reaction is equals to what? Rate constant. So let's look at the units of zero order. Like I said before, we use this mole per liter or mole per dm cube. This molarity sign 1 minus n. So if n is zero order, 1 minus n per seconds. So if n is zero order, 1 minus 0 is what? Is something as 1. So unit of zero order is something as unit of rate constant, mole per seconds. And mole per seconds is mole per liter per seconds. This is the unit of first order reaction. It can also be mole per dm cube. Mole per dm cube per seconds. So your time can be in seconds, it can be in days, it can also be in years. So depending what you are given. So this is a unit of what? Of a zero order reaction. Okay. So zero order reaction gives a negative what? Slope. The slope is negative, and the slope is minus. You can as well rearrange this formula to be like this. You can use this one if you are asked to find the concentration at time. If you are asked to find, for example, the rate constant, for instance. So that's, you just bring this, if you bring this one here and bring the other one here. So rate constant will be K is equals to initial concentration minus concentration at time, or what final concentration divided by what time. If you ask to find K, rate constant, you use this formula. You can also say AT minus, even if you use AT minus initial concentration equals to minus K, you still get the same answer. Right. Let's solve some exercises. The decomposition reaction of ammonia is a zero order reaction. Calculate the amount of 0.900 mole per liter ammonia left after 250 seconds. If the rate constant for the reaction is 2.66 times 10 raised to the power minus 5 mole per liter per seconds. So you can see this reaction we are told is a zero order reaction. In some cases they won't give you the order of the reaction, but you can use the unit of specific rate constant to note it. Like I mentioned earlier, if you have forgotten, you use this 1 minus n per seconds or per time. So whatever you have here, match it to. If you put 1 minus 0, if it's zero order, it will be mole per liter per seconds. If it's first order, 1 minus 1 is 0. Anything raised to the power 0 is 1. So it will be per seconds like that. So what are we actually looking for? Calculate the amount of 0.99 mole per liter ammonia left after 250 seconds. So we are looking for the concentration at time. This one is the initial concentration. So put our formula. concentration at time is equal to initial concentration minus KT. So our initial concentration is what? 0.9. Our K is 2.66 times 10 raised to the power minus 5 times 250 seconds. Okay, so let's 6.65 times 10 raised to the power. So 0.9 minus 6.6 times 6.65 times 10 raised to the power 3. When you subtract this, it will give you this value 0.893 mole per liter. So what should be the unit of concentration? You are given the one initial concentration to mole per liter. So the unit of final concentration or concentration at time also be what? Mole per liter. So that unit is very, very important. Look at, I use A to represent this, isn't it? So, but we are actually talking about ammonia. So concentration of ammonia at time is equal to the same value, 0.893 mole per liter. Let's look at first order reactions. First order reactions are reactions in which the rate of reaction is directly proportional to the concentration of the reactant species in the rate law raised to the power of 1. So look at this equation. A, reactant to give a product, or A, the composite to give product. So if I'm to write the rate law for this reaction, we can say that rate is equal to rate constant, this concentration of what? Of A, raised to the power of what? 1. To show that this is what? A first order what? Reaction. You also have this A plus B, react to give product. So for first order reaction, it means that one of the reactants is first order and the other one is what? Zero order. So that's what it means. So 1 plus 0 will give you what? 1. It shows that what? This is the first order what? Reaction. Formula for first order reaction. So lane of concentration at time equals to minus KT plus lane of concentration of what? Of initial concentration or this. So if you take the log of both sides, if you take the log of both sides, you will have a log concentration at time is equals to minus KT divided by 2.303 plus log of what? Initial concentration. So if you have the formula I want to use for first order reaction to give you the same answer. If you want to use this, no problem. Want to use this, no problem. So what it means that if I have to plot the graph of first order reaction, you see the same negative slope we're going to have. So familiar with this. So the slope of this graph is going to be this. It's going to be this. Minus K all over 2 divided by 2.303 or minus K. If I'm using this, it will be minus K. If I'm using the name, that's this equation, it's minus K. So if it's this one, it's minus K over 2.303. You can see it's a negative slope. The concentration of reactant decreases as time passes. So the slope is a negative slope. It's either minus K. If you're using lane, that's minus K. So what we're going to have, if it's a log, minus K over 2.303. What should be the unit of first order reaction? So the unit of first order reaction is per seconds, because if you use this formula 1 minus n per seconds is constant in all the unit of rate constant. Per seconds is constant. So if I put this n represents order of reaction as first order reaction, 1 minus 1 will give me 0. So anything raised to power 0 is what? Is 1. So the unit of first order reaction is what? Per seconds. So if you are given any calculation question and the order of reaction is not mentioned there, but the unit of the rate constant is written, through that unit you know the order of reaction and know the formula to use. So not be using, if you are given per seconds, you not be using a zero order reaction instead of using first order reaction. The answer will be wrong. So let's solve as an exercise on a first order reaction. Calculate the concentration of 0.7 mole per liter of N2O5, that's the nitrogen 5 oxide, left after 200 seconds of decomposition if K is equals to 5.05 times 10 to the power minus 3 per seconds. So through this unit per seconds, I know that is what? A first order reaction. It is a first order reaction. So I want to say that some examples of first order reaction includes reductive decay processes, decomposition of hydrogen peroxide H2O2, decomposition of nitrogen 5 gas phase, decomposition of nitrogen 5 oxide, gas phase decomposition of dinitrogen 1 oxide N2O. They are all examples of first order reaction. So look at this question. Calculate the concentration of 0.7 mole per liter of N2O5 left after 300 seconds. So we are looking for the one that's left after the time. At time, the one that's left. So this is initial concentration. So what you know that at the end, the concentration at time, that's final concentration will be what? Lesser. It will be lower than this. If you're not lower than this, it means you're wrong. So minus, what's our K is given? 5.05 times 10. Times 10 raised to the power. Raised to the power minus 3 divided by 2.03 times 300 plus log 0.7. So the antilog of this value so give us, so we're having 0.15 mole per liter. So your unit of your concentration is mole per liter. Let's start an exercise. The following data was obtained for the conversion of nitrogen 2 oxide to dinitrogen 1 oxide and nitrogen 4 oxide. So this is the equation for the reaction. This experiment 1, 2, 3 was performed on this reaction. Initial concentration in mole per liter of this reactant. So it was gotten to be 0.060 mole per liter. Experiment 2, 0.120. Experiment 3, 0.180. So this is the value for the initial rate of the reaction. So use the data to obtain the order of this reaction. So if they ask something on the question, we just use the coefficient and just say the order of reaction is 3. That's what we say. The coefficient of a balanced reaction, you don't use it to predict, cannot be used to predict the order of reaction. So it's still experiment that can be what determined. So let's solve this thing to know the order of reaction. So rate law for this reaction, rate. So the reactant is NO. since you are looking for the overall order of reaction, you don't put that 3 there. You can use any letter to designate it. You can use A, you can use X. So I only use X. If the reactant are 2, there's another reactant there, I will use what Y. You can use A or B, any letter of your choice.
We are asked to use the data. We are asked to use the data to obtain the what order of the reaction. We are looking for the order of the reaction. So remember, this is the order of the reaction S. You have to find this S. So have R. We use R to represent rate. R represents rate. So you can use any of them. Maybe R3 over R1, R3 over R2, or R2 over R1 to give you the same answer. Okay. So what's our R3 here? And I might place the number that is higher above. If you place the lower one, if you place R1 and bring R3 here, you still get the same answer. So R3, what's the value for R3? Initial rate, that's 16.56 times 10 to the power minus 3. All over R1, which is 1.884. So equals to this K, we're going to eliminate K. We'll eliminate K. So what's R3 is what? What's the concentration for R3? 0.18 raised to the power S. What's the concentration for R1? 0.06. Okay. So I'm going to be cleaning this board so that we'll have a wider space. So when you divide this, 184 divided by 16.56, we'll have 9. Okay, look at this. Which number will I use to multiply? If I divide 0.06 divided by 0.18, it will give me 3. So instead of putting 0.18, I will now put 3 times 0.06. 3 times 0.06 will give me 0.18. So 3 times 0.06 raised to the power S all over 0.06 raised to the power S. So 9 is equals to. So you have 3. This 3 multiply this raised to the power this X times 0.06 raised to the power X divided by 0.06 X. So these 2 will go out. This will be out. This will be out. So 9 is something as what? 3 raised to the power 2 is something as 9 equals to 3x. So 3 will cancel 3. So x will be what? Will be 2. So the order of this reaction is what? 2. Order of the reaction is what? Is 2. Of this reaction is 2. So our rate, so I'll now substitute it here. NO is what? 2. Part 1 for order of reaction and rate law. So next video our uploading will be, we'll be doing the second order reaction and many more exercises on the order of reaction and the rate constant. Okay, thank you for watching. Do not forget to subscribe to my channel, like and share. Thank you.